guy helping engineers solve problems, but as well helping companies help engineers solve problems. In his talk, he will reveal the connection between behavioral psychology and coding, and actually teach us how to manage our mental energy to stay focused on what really matters. Please, one big round of applause for our first speaker.
Thank you. Welcome to the first stage. Thank you all for coming. There are couple of more chairs here in between. We can do the defragmenting thing, as in all computers, who's old enough to remember what it is. There is a camera there, so please don't stand right in front of it. Thank you. All right. Coding fast and slow. We're going to try and apply Professor Kahneman's insight to improve developer practices and efficiency. So who is Professor Kahneman? He is one of the most important figures in behavioral psychology like ever. Unfortunately, he passed away just last year, but his studies are with us for generations ahead. He is a Nobel Prize laureate in economics of 2002. And this is where you go like, what? Economics? What it has to do with economics? So this is the official nomination for having integrated insights from psychological research into economical science, especially concerning human judgment and decision-making under sentencing. So what behavioral psychology has to do with economics? It's easy. So if you ever took any economic class, this is how it goes. People are rational, this is why markets work. Supply, demand, people prefer to buy what is cheaper and won't buy what is more expensive, etc., etc. So this is kind of where every economics teaching starts. And then Professor Kahneman goes and no, that people aren't rational. Here's 50 years of study that proves that people are actually irrational and won't make the decisions the way you think they will. And oh wow, they really aren't. It's probably a profound effect in economics. Here is a Nobel Prize for you. Thank you very much. And then economics, people are rational. Let's pretend that they're rational. This is why markets work. So this is exactly how the world looks like. We ignore stuff that it's too complicated, and this is what economists do with the study of Professor Kahneman, although he got the Nobel Prize. But what we're going to try to do is apply those insights into our daily lives as developers and software engineers. The name of this talk and a lot of the content comes from this book called Thinking Fast and Slow. This is why coding fast and slow. And if you want to read one book of Professor Kahneman, this is probably it. It was written not so long ago, so it incorporates a lot of his studies as opposite to his earlier books. And this one is one of the most approachable. There are others which are much harder read, but this one is very, very approachable. So to get you started and continuing on the effort to wake you up after lunch, here is a very short example from his book. Now, what I want you to do is to shout the answer that comes to your mind without thinking too much, okay? As I ask the question, just give me the answer immediately, whatever comes to your mind. So a bat and a ball costs $1.10. The ball costs $1 more, the bat costs $1 more than the ball. How much does the ball cost?
5 cents.
Okay, excellent. So I cannot hear you because of the noise, but if you said 10 cents or thought 10 cents, you are a normal person like everybody else. If you shouted 5 cents, you're probably cheating, you know about this problem before, and you're just doing it for everybody else. So every 5 persons, because 10 cents for the ball, and then $1 for the bat, $1.10 will be 120. The correct answer is 5 cents, because then the sum of them will be $1.10, and that's exactly the question. Well, we're going to talk about why whoever thought about 10 cents made this mistake. But there is something else in play. We're going to get to it in a second. So my name is Baruch Sadogursky. I'm at jbaruch everywhere on the internet, and I'm a head of developer relations at a company called TaxCare. We are hiring a lot globally remote, so take a look at our hiring page. There are a lot of great positions there. I'm a nerd of developer productivity. This is how I got into this research in general, and everything I'm doing, I'm trying to apply to how to be more productive for a developer. My background is I come from development, then DevOps, and now thinking about developer productivity and security a lot. A Java champion, wrote a couple of books that related to Java and DevOps and developer productivity, and basically everything in between. The most important slide of this talk is this, show notes. If you go to speaking.jbaruch with the .ch, thank you Switzerland for letting me abusing their top level domain, the slides are already there. The video I'm recording right now, if you're standing before the camera, that might be a problem, but hopefully you don't. All the links for everything we are talking about today, all the work of Professor Kahneman and everything else, everything is there, and then a small raffle to thank you for here. If we will have time for questions, I have also a little bit of gifts for the best questions that you will ask today as well. So, in the bottom of every slide, right there, speaking.jbaruch, this is Shift and jbaruch here as well. Okay, so let's get back to the question why you wanted to say 10 cents. Why you wanted to say that? Professor Kahneman found that in our brain we have two systems. Unimaginably, he calls them system 1 and system 2. So, system 1 is very fast, intuitive, automatic, emotional, cheap and eager to answer. When we thought about the problem, when we didn't think about the problem, when we just saw two facts on the screen, the paper of $1.10 and then the question about $1 less, this triggered immediate pattern recognition. $1.10, $1 less, 10 cents. Automatically, without any effort. Oh, I know the answer. Very, very fast. This is system 1 at work. When you discovered that this is a wrong answer, you ask yourself, okay, that was embarrassing. Why did I answer wrong for such a simple question? I need to think about it for a second. And this is when you actually turn on the system 2. System 2 is the opposite. It's much slower, it is analytical, you started to do the math. It is controlled, you control that you go correctly through the steps and don't jump to any conclusions. It's logical, mathematical operations, and it's expensive and lazy. It didn't turn on automatically when you saw a puzzle because you need to make an effort to make it work. So, basically, system 2 needs to make an effort to shut down system 1, prevent it from answering, and answering instead of it, right? System 1 is going to be, oh, let's think about it. That's all I do. This is an effort that we need to make. Let's do another example. This is a simple, very simple Java puzzle, Java code that something is wrong with it. So, we don't have a lot of time, so let's do it quickly. Let's take a couple of seconds. Whoever recognizes the problem, just shout it out and try to do it. Line splitting. I'm sorry, I can't hear.
Well, I don't actually know Java. This program, if this program seems like it throws an error if the word you put into it is longer than one character.
Longer than one character. No, it will actually work because we'll read all the lines from files. So we read all the lines from there.
I thought about this like each statement you go.
Yeah, no. If the line starts with something, that's also fine because it's about start of line. This is a lazy or operator. If this is false, this won't even be evaluated. And obviously it should have been either one or this, or it can be lazy and without the here, and then it will work as well. Anyway, this is the system too, and that's the only thing that I wanted to do. Now we're going into the next puzzle. Now what I want you to do is shout really loud the color of the letters. Let's do it.
Yellow, orange, red, blue, green.
Good job. Now what you wanted to shout is actually what is written on the slides.
At least on the first one, later on my brain got used to it.
Yes, especially in the first one, because then you kind of already know that you need to engage system 2. That's exactly the thing. Now, the reason why it was even harder for you now is because your system 2 was previously engaged with the puzzle. Right? You depleted your mental energy by using the Java code and trying to figure out what's going on. And your system 2 was more tired and even less engaging than usual. This is this very simple proof that you have a mental core that won't be depleted. And the system 2 will get tired and network as easily as with full battery. Now, the interesting thing about it is Professor Kahneman figured this out 50 years ago by doing experiments about like what we just did with everything controlled environment and everything else. Now, just a couple of years ago, scientists found a physical proof of this fuel in our mind. This is a research called attention and capacity limits in perception, cellular metabolism account. Cellular metabolism means our brain cells can get tired. Right? There is a lot of stuff like this in this research, and I have no idea what it is. So obviously I asked ChatGPT, explain attention capacity and limits in perception to the very cellular one part of the left. Barney, it's a very American thing. This is Barney the Dinosaur. There is a kid show that Barney explains stuff Barney style. So I asked to explain cellular metabolism to the Barney style, and this is what we got. And what we got there is that the smartphone battery, the brain changes Earth. The problem says that our brains have this capacity of manageable tasks, and like closing the exercise battery, your brain starts to save energy by paying less attention to less important stuff. That's exactly what happened with the words. You paid less attention because your battery was a little bit more depleted after you looked at the Java code and stuff. Well, so there is stuff in the paper that I don't understand, but the idea is that cellular metabolism is environmental flow, and it's a finite energy supply. And what the research found, that there are two modes, high-load mode and low-load mode, which suspiciously looks like system 1 and system 2, and was found by Professor Kahneman by observing human behavior. So let me ask you, which system do you think we use for coding? System 1 or system 2? Who thinks we use system 1 for coding? Who thinks we use system 2 for coding? Well, majority of us. So system 2, especially the part of analytical, controlled, and logical, seems a lot like the right answer for what we use for coding. This is exactly what software engineering is. We're going to talk about what of system 1 can help us and why in a second. Now, another research from another great psychologist about the flow research that invented the whole flow that all of us as software engineers probably know. The state of effortless concentration so deep that people lose the sense of the time themselves and their problems. To experience flow writing code ever? Everybody, I guess. The most puzzling part of this part is the interface. Now, this looks very, very strange because if we use system 2 for coding, how it can be effortless if it is the lazy and expensive system? That's a question that we don't have an answer, but this is true for our brain. Our brain does something that our smartphone, analogy with the battery, can do. There is no magic mode that will use a less battery for a power-hungry app because the app is excited. But it is true for our brain. We can use system 2 effortlessly without spending mental if we are in the flow. This is magic that our brain can do. Now, the problem with flow is that attention control is very expensive and getting more expensive by the day. Professor Daniel Kahneman, who's another great researcher, spent decades on researching human attention. She published a book last year called Attention Span, summarizing her findings, and there are some very profound and very disturbing findings in the book. For example, how many times do you think people check email in a day? Shout it out. 13? 100? 17? 17? Okay, nobody pushes. We can't 77. Company, I have like a card for the t-shirts. Alright. Now, I was shocked because I said, okay, you know what? 20 looks like a day that I check emails. 77 was a complete shock. And then I actually tried to count, and it was very close to 77 and very, very scary. Okay, next one. Our attention span divided to how many seconds per screen? 4. No. Okay, I'm going to go in seconds. Sorry about that. 47 seconds. That's still not a lot. Think about it, you look at the screen, including your code, for 47 seconds on average. Of course, you have spans of multiple minutes when you actually write code and concentrating, especially if you are in flow. But on average, 47 seconds, that's pretty scary as well. And the most important, it takes how much time to return to focus after interaction?
10 minutes.
2 minutes. 23, 24, 15, 25. 25. Now, you know what it means, 25 minutes? I'll give you one example for understand how devastating those 20 minutes are. Software engineers here who have like a build, like if you're Java, Maven, Gradle, NPM build, whatever build you have. So, how many of you have a build that is shorter than 2 minutes? Okay, one hand, two hands. Shorter than 5 minutes. Another like 4 hands. Okay, so everybody here, 90% of the people here have a build that is longer than 5 minutes. What do you do for those longer than 5 minutes? Are you staring at the screen looking for the build to finish? No, no.
I'm thinking, how can I improve the build? How can I continue?
How long your build is now? If it's 7 or 10 or 15, your build now is 25 minutes. You can back to it in 25 minutes, no matter how long it takes. This is profound. Alright, let's do new exercise. Not another Java puzzle. Very, very simple stuff. Let's start with this code.
I know. It says system.out, even though the function is defined as public static void with void, meaning that it returns nothing.
Okay, alright, let's go. We really shouldn't do currency in dollar. It's quoting the longer size, the output size, very good idea. Okay, anyway, let's exercise our system for a little bit. Let's do something fun. Let's go triangles. Triangles is going to go for the sufficient. Here, 27, we go for 7, 8, here's that triangles, triangles, triangles. This is system 2. All of them system 2 engaged. Triangles. 16, 13, 28, 18, 21, 5? 5, okay. 12. Oh, 18, you get a t-shirt, good job. 18. Last time, let's go home. Alright. Second thing is, let's use this. Same double as an amount, but obviously there is something else. It doesn't really ask about that. Division by 100. Yes, good job. Think you said it first? Who said it first? Division by 100, yes. Don't forget to come for the t-shirt. Excellent, yes. So total amount here, tax rate is actually divided by 100. Yes. Okay, so the second puzzle, let's regular figure on the first one. But it looked not easy for you because you did context switch. You worked on Java, and then you came to triangles, and then you went to Java again. This context switch made your system to work harder in deciphering important stuff. All right. Cool. All right. Okay. Now, the problem is you deplete your fuel by context switching. That's exactly the problem. You are not in the flow because of the context switching. Remember, the flow must be uninterrupted. Okay, people, if you want your video, start protecting the camera view over there because now no one can see anything. Okay. You're going to fail because you don't think because of the context switching. It is a lose-lose proposition. You need more fuel because you are not in the flow. Remember, the effortless is in the flow. When you think about code and you're not in the flow, it is expensive and more fuel. But you actually have less fuel because of the context switching. So you lose more fuel, but you need more fuel. It is a lose-lose. Okay, so let's switch some stuff because this is 45 minutes talk and get to actual solutions. So I want to take you here. Now, the real outcome of this is that you start to run on system 1 instead of running on system 2. You actually start running code in an intuitive manner, which is not necessarily a bad thing. Intuition is execute skill response and generate skill intuitions after adequate training. We have adequate training. We know how to write code. So we can write code without switching to system 2. There is an entire notion of 10,000 hours of training that was introduced by Malcolm Gladwell Outliers that says that if you practice enough, you can excel without even engaging system 2. The problem with that is that it works for predictable tasks. What you can do with intuition? You can play tennis and get excellent about it. You can play musical instrument and get excellent about it. You can drive on system 1 without engaging system 2. Have anyone got into their car and find themselves in a completely different location where they wanted to go, maybe on the parking lot of their office on the weekend? Because that was driving on system 1. You didn't even engage system 2. So there is a lot of stuff that you can do on system 1, and that's like the 10,000 hours of practice that moves some stuff from system 2 to system 1. Yeah, driving golf and tennis and music playing and safety drills for firefighters. I will leave this one as a little bit of teaser to read Thinking Fast and Slow. It's over there. Now, the thing here is about rapid feedback. Plan, execute, observe, improve. If the feedback is immediate and very clear, this is where practice will perfect. Think about all this. That's about immediate and very clear feedback. When you learn how to drive, if you speak too much, when you see that you're driving down the road, you will correct immediately. Now, software might be like that, and then in system 1. But software that you write on system 1 is not great. Software that you write on system 1 is what I write the OK code. The real insightful, the real stuff that you come up after thinking is probably somewhere here. And this is not available for you because you depleted your mental fuel. So you generate an OK code, which is not very detailable. Now, let me ask you, what do you think sucks less? Bad code or OK code? Which is less bad? Who thinks OK code is better than bad code? Couple of hands who think that bad code is worse than OK code. Just one hand. Okay, I'm with you on that. Bad code is actually better than OK code because bad code is visible. It won't compile, it won't pass code review, it won't pass quality gates. This is just bad code. OK code flies under the radar. It looks OK to us. We don't have mental fuel, we're tired. We are on system 1. It looks OK to our that does our PR review. They're definitely on system 1 when they're reviewing your code because they have sent their system to their own code. And it looks okay to the pipelines because pipelines by definition system one. They are algorithms that are just written and read for stuff that we thought about. So next thing you know, you have a full product. And that's the problem without it. Okay, we have 1 minute and 40 seconds to talk about fuel saving techniques. The idea is to have enough mental fuel to last all day for us to be able to engage system 2 when we need to engage it. So what we can do? Time management strategies. Like Pomodoro and Pomodoro technique. Wait, Pomodoro technique is about interruptions. You have to interrupt for every 25 minutes. Right? How does it work? Well, the idea of the Pomodoro technique is that you are focused for at least 25 minutes. If you are on the phone, you keep going. And then task batching and all this great kind of stuff. I have one recommendation in this area, and that's a tool called Reclaim AI. This is a tool that replaces your calendar, and it moves stuff around, so you will have time to focus without compromising your availability. People will see that you are available in certain times, and then the Reclaim AI will move your focus time and stack it together so you will have more time to work and move or propose to move your meetings to other time. This is very, very critical. It knows how to block time, batch tasks, but also allows access to you for the important meetings to have. Mindfulness and cognitive practices like meditation and reflective practices, single tasking, this is all very important stuff as well. Workspace and interruption management, like workspace organization. Should you really work in this noisy open space when your entire team is in a different office? What does being in the office actually means to you? Notification management, you know all this stuff. Prioritization techniques, the ability to say no to what will be a distraction. Physical and mental well-being, stuff like physical exercise, go to gym, and breaks and downtime. The most important, the only way to recharge your mental batteries and restore your system 2 capabilities is sleep. There is no other way. There is tons of research that proves that, and Sarah Mednick she's one of the lead developers, lead researchers in the area of the importance of sleep. She wrote a couple of great books, The Power of Downstates, on how to recharge. Recharge here is exactly recharging your system 2, and take a nap. This is one of my favorite books because it teaches you how to take a nap. So again, I will leave it for you to read. Let's keep going. Now, AI. We need to use AI, but we need to use it smartly. Right tools for the job, specialized agents and this kind of stuff, and local AI, this is all important as well. Agentic AI, as long as you do it right, stuff like JetBrains Juni and Windsurf and Visual Studio Code and all this stuff. Okay, what else? Here is another important part, cognitive practices. Automate everything, short feedback loops, and delegate to tools is important to prevent context switches. Delegate to pros where needed. Here is a simple diagram for life on how to know where to delegate. Is the task your core expertise? Is this what you paid for? If it is, do it. If it's known, is it easy to learn? If it is easy to learn it, and then do it. If it's not easy to learn, do you have time to learn it? If yes, learn it, then do it. If no, delegate. Simple, powerful, works every time. Example of the path of not your core expertise, not easy to learn, you definitely don't have time to learn it, is security. But the problem with security, that it's being delegated to you constantly. Your boss is telling you, you need to make sure that your app is secure, but you cannot, so delegate. One of the places to delegate is to us, TaxCare. This is why they pay me for being here, for this whole slide. And with that, here is the call for action. Save mental fuel. Time management, workspace management, mental well-being, engineering fewer interruptions with all the correspondence, and then delegate to taxpayer and others where needed. With that, thank you very much. Everybody everywhere, the new shift, speaking Dodge Baruch, the video, the thing, everything is right there. T-shirt, t-shirt. For everybody else, thank you very much.